Alright, Bismillah, Alhamdulillah, wassalatu wassalamu ala Rasulillah wa ala alihi wa sahbihi wa man wala. Allahumma rabbi syrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli, amma ba'du. Guys, this is just a small attempt on my part to quickly revise on the second part of our discussion from this chapter, limiting factor analysis, and then for me to continue on the last part of this particular section of your chapter, which is on the simultaneous equation. Well, last time we talked about the fact that we have multiple limiting factor, and we said that to solve the problem of multiple limiting factor, we use linear programming. By that we mean we use two methods. Number one, we use graphical method, and number two, we will do the simultaneous equation. Okay, so now what I'm gonna do quickly is to point out some key terms that we have learned from the graphical method. Okay, graphical methods. What are they? Well, we have number one. We have on the graph itself, we have something called optimal point. Optimal point, and you guys know that the optimal point will give you the OPP. Okay, that will give you your OPP. Like, for instance, last time we do purse, P for purse, and H for handbag. So on that particular point, you know how many purses that we need and how many handbag that we not that we need, but how many of them that we would want to produce and sell. Okay, and apart from that, you know that from optimal point, when you get the OPP, you can get the maximum contribution, which you compute by using the objective function. Okay, so that is what you use to find your maximum contribution. If you still remember, and you can refer to your cost note, you know the objective function was to find the contribution is equal to $5 for every purse plus $6 for every handbag. Okay, what else did we learn last time? We learned about something called feasible region. Feasible region, alright? It's a region in the graph. Region means area, whereby in that area, any point on or inside within that region, including the boundary of that region, any point within that or on the boundary itself is a possible combination of your product mix, meaning how many P and how many H, right? Although it may not necessarily give you the highest contribution, but that's possible combination. Why do we say it's possible? Because it is possible because the resources are sufficient to produce that amount of combination of purses and handbags. Alright, that's your feasible region. And don't forget, we have something called ISO contribution line. ISO contribution line. Alright, whereby when you find your ISO contribution line using trial and error method, if you still remember that, and you use that ISO contribution line and you follow that gradient to really slide outward from the origin, slide outward away from the origin to get a point whereby that is the last point that when you are using a ruler, that's the last point that touches your ruler, and that point is your optimal point, which gives you your OPP. Alright, so that very much concludes what we have learned so far from this particular part of the chapter, multiple limiting factor, using the method of graph. Okay.